Welcome to RF lecture series. In this series, we'll discuss about the filters. RF filter, an electronic filter or circuit that performs signal processing functions specifically to remove the unwanted frequency components from the signal and to enhance the wanted bandwidth of signal. So RF device includes some kind of filtering on the signal transmitted or received. RF filter enables the required frequency to be passed through the circuits while rejecting the frequency that is not needed. So here in RF receiver will receive only the signal whichever is required and will remove all the carrier signals and noise signals and will reject from the filter. So now let us consider this is the RF filter, and here you can see when the signals in our receiver systems, here we have the different signals which is combined and it is sent to the filter block and in receiver block. So in receiver, this what filter does is filter will allow the signal which is necessary to be received, and it rejects all the remaining signal which is not required. So here this picture depicts the whatever I said in the previous slide, like introduction. So that filter will allow only the desired frequency and it will reject the remaining frequencies. There are different types of filters, that is low pass filter, high pass filter, band pass filter and band stop filter. So low pass filter, it will allow the frequency or in the low frequency, that is it will allow the frequency till the cutoff frequency. And here you can see this picture that it allows the frequency, it will pass the band of frequency till the cutoff frequency, and it is the whichever the frequency of higher frequency, it will stop the band till the cutoff frequency. This low, it will allow the low pass filtering. Whereas in high pass, the high pass signal filter will allow to pass the signal after the carrier frequency. So this is the difference. You can see this like between the low pass and high pass filter. The low pass will allow only the lower frequency ranges till the carrier frequency of mid frequency. After that, it will stop the frequency. Whereas in high frequency, it will allow the signals to will be started from the carrier frequency. It will pass after the frequency, I mean carrier frequency 1. Here you can see this is the pass band. It allows the frequency after the carrier frequency. And then the remaining stop band, it will be attenuated. The signal will get attenuated, will be stopped. And this is the band pass filter. The band pass filter will allow the frequency. This filter will allow the frequency between the bands, like mid-range of frequency, like for F1, if we want the frequency between only the 5 to 6 gigahertz, that only the band between the 5 to 6 gigahertz only it will pass the band. Remaining band between this, for example, let us consider this is 1 to 10 gigahertz, and in this we require only the 5 to 6 gigahertz of band, that is F1 is 5 and F2 is 6 gigahertz. So it will allow only the frequency band between this F1 and F2, and remaining that is 5 to 6. Remaining all the other bands will be of lower frequency, it will be rejected. That is nothing but it will be stop band. And then band stop is, this is the low high pass filter. Low high pass filter means the frequency will get band stopped. That is this only the mid region between this will be stopped. So here the frequency will allow in the low frequency. The signal also will get pass, and then here also will get pass. So mid frequency will be like band stop. The signal will be band stopped between the low high pass. This we call as a low high pass filter. So regularly we'll use only the low pass, high pass and band pass filter. Here you can see in the receiver block will receive the different types of data like images, frequencies, signals, or whatever it is. So here this intermediate, whatever the data is coming in, this RF filter will filter only the signal. It will send only the signal whichever is required. So remaining this unwanted images, signal and this intermediate signal all will not be sent. So this RF filter block will be responsible only with the RF tuning. Only it will send only the wanted signal whichever is required. So remaining all the signals will be the band rejected signals. So now we'll see the filter types of off-chip filter and on-chip filter. On-chip filters. Here I'll show this is a picture of off-chip filter where we have the LC filter, SAW filter, microstrip filter, dielectric crystal filter, resonator filter, and crystal filter. The SAW filter is like basically we'll use in all the transceiver model. We'll have the SAW filter. LC filter is when we go for the frequencies, whenever it is required we use the LC filter. This LC filter also will use in the RF transmitter and receiver block. In microstrip patch filter is like high frequency filters. Whenever they go for the high frequencies applications, we use this resonators and microstrip filters. There are the different technologies of using designing this off-chip filter. So here we can see this LC filter is for low frequency applications of typically of 10 megahertz to 2 gigahertz. So the cost is low, and we use the resonators like for low frequency up to 2 gigahertz of and their cost is like medium. So soft filter is like ranging from low frequency up to till 2 gigahertz only, but the frequency that cost is between this mid to okay, it will be affordability. Like microstrip patch and in a filter we use the microstrip filters we use up to high frequency, and this relative cost is also low, but the thing is like we have the fabrication technologies we use like printing fabrication thing. And next is of crystal and ceramic. This is all the low frequency applications, and we use for low frequency application we use this type of technologies for designing the filters. Next is on-chip filter. The on-chip filter will divide this filter into two categories like digital filter and analog filter. We'll not discuss about this digital filter, it is not in our part. In analog filter, we'll go for the passive filter and active filter. In this, we'll discuss of LC filter and electroacoustic filter. In active filter, we'll have the switch to capacitor Q, enhanced LC and GMC model. We'll not see of this active filters thing, but we'll have the in RF frequency model. We'll be very deep into this LC filter of passive filters type thing. Yeah, you can see the difference between this whatever I said is of off-chip and on-chip filter. So here you can see this off-chip filter will have the high Q disadvantages, and then whereas it will be having on-chip filter will have the low Q factor, low quality factor. And here you can see this like in off-chip filter will have the parasitic elements will be more. This is the disadvantage of this using off-chip filter. And here and we'll have the high area of consumption thing we have to consider. But in advantages of like we can go for the we'll have the low noise and low loss and low noise. This is the advantage of off-chip filter. But this off-chip filter is we have to place in a separate IC block, whereas in on-chip filter we'll have the advantage of less parasitic elements we not required because we are integrated into the one single IC. But it is like it will have the higher loss and high noise. So this is the disadvantages. So we'll not go for the off-chip filter. Most of the applications they'll see this thing like what are the things they have to be considering for off-chip and on-chip filtering thing. And this is of low area consumptions. This is the advantage of using this on-chip filter, but it has the low Q value we have to consider when we are designing this filter thing. We'll have first thing we have to the criteria of higher quality factor. Here you can see this different off-chip filter. So here you can see it will be like this is a low pass filter, and this is the inductance capacitive filter. Here you can see this. This is the high pass filter. Here you can see this is the capacitive filter type, and this is the band pass filter. Here you can see this is a circuit diagram like inductance. We use the LC model. So this in oftenly we use this off-chip model like LC model is an good thing for calculating for designing the filter thing. We suggest to go for the LC model type so that we can able to observe all this criteria of attenuations and what are the quality factor and what are the frequency which it can be defined and work for the filter. So we go for this thing, and based on our that like pass banding or high pass or low pass filter or band pass and band stop filter, we go for this type of the selection. The circuit diagram is we usually go for the transmission. From the transmission, we'll design with this parasitic of LC model, and then we go for the transmission line model, and then we'll go for the filter design model. This is what technology we use for the microstrip filter. And here you can see this model, like this is like band stop, which is here we are going to stop one of the, will allow one the frequency of this particular band, and remaining band will be the band stop filter. Now this is the on chip filter model. So here you can see this is the GMC model of filter, and this is the acoustic of switch to capacitor model here. Here we use the FET transistor model, whereas when we go for this transistor model will work for the intermediate frequency thing, it is okay, but when we go for the high frequency, it is notable that the frequency will get disturbed, so that transistor may get damaged, so that we not when we go for the high frequency application, we go the LC model is preferably. Will not go for this on chip type filter model of like GMC model or switch capacitor model filter. Then thanks for watching, and in next blog we'll discuss about the oscillators.